Okay, so this is the second part of number 2, and we want to actually find what the area is. We were looking for, again, the question says find the maximum possible area. So we found the value, okay, that's of x is going to give us that. We know that the second derivative is negative, so that's going to be in my first derivative. That was actually my first derivative test. I didn't really write it out, but if we wrote it out up here, a prime, then that was right over here. That was the square root of 5 over 3. That was my critical number. There's my a prime. And then we had a concave down at a double prime, so that means we have a relative maximum. So we're just going to try to evaluate this. And that's going to be a of the square root of 5 over 3 equals. So we're going to put 5, every time we see this, is going to be put a 5 over 3. The square root of 5 over 3. Well, that's going to be kind of a hassle to kind of work it out in radical form. You could. It wouldn't be a lot of fun, but we're just going to do this with a calculator because we're just going to want a numerical answer. So let's see how we would do this. And then I'll show you another way to do it. It's kind of nifty, I think. So first of all, we're going to deal with 5 over 3. The square root of 5 over 3. So we'll turn this on. We're at our home screen. And then what I'm going to do is going to go square root, that's second x squared, and I'm going to just put 5 divided by 3, 5 divided by 3, parentheses, and enter. And that gives me 1.29. So that's my critical number okay, that's my critical number in decimal form. So I'm going to store that. So we'll store that. Good, I'll store that in alpha A, enter. Now we want to put that in this equation, so we want 20 times alpha A, so 20 alpha A plus, minus 4, and then alpha A, and then we're going to cube it. Now you don't have to put caret 3. What you can do is you just hit math 3, and that'll make that cubed. So there's our value of the function. We're going to square root of 5 over 3 in our function, and we press enter, and we get 17.21, so that's our area. That's your answer. So now you're done. Okay? So area of this is equal to 17 point, and if we round off to 2 places, so make that approximately 17.21. Okay? Now I'm going to show you a different way to do this, and some of you might like this. We can use our calculator, and we actually won't have to do anything. We won't have to write anything down after this, I think. Right after this. So we're going to start right here, and we're going to be able to avoid all this stuff. And I'll show you how to do this, so try to follow. You guys that want to really get good with your calculators, and this might come in handy a little bit later also. So I'm going to clear all this stuff out. And what I'm going to do is I'm going to put this function right here in my y1. So that's going to be 20x minus 4x squared. Now that's my function. Oops, sorry, x cubed. Oh man, now we're going to mess. Math 3. Okay, so 20x minus 4x cubed. All right, so that's my function. Now I want to do the derivative, and sometimes they're not easy to take mechanically or by hand, but this is a real easy way to take the derivative and graph it. Now watch. I'm going to use Math 8. Now that's how we take our numerical derivative, and I don't know if you remember that, but if we had Math 8, that's going to give me my numerical derivative. I think we talked about this back in chapter 3, I hope. Okay, now what I want to do is I want to take the derivative of this, which is in y1, so I'm going to hit vars, and I'll move over to y vars. Now watch carefully and press enter, and I want that original function y1. I can choose any of those, but in this case I'm going to use y1. I'm going to press enter, and that puts that there. Then if I press comma x and comma x, I'm going to do x with respect to x in parentheses, that will actually graph the derivative of this. In other words, that would graph 20 minus 4x squared. Now what I'm going to do is I just want to look at that because I want to find my critical number, so I'm going to go back up here. turn that off. So I look at just that. And then what I'll do is I'll go to zoom 6 again. Actually, I'm going to go to zoom 4 because I know it's going to be smaller. And there we go. Now this is my derivative. I'm just graph my derivative. And if I want to find where it changes from positive to negative, which is going to be the maximum, remember we're looking for the relative maximum. So that's where it changes from positive to negative. So remember, this is right over here. We're not worried about the negative because that's going to be positive. So this is, it's positive over here, it's negative here. So that's basically where my function changing from positive to negative. So I'm going to have a relative maximum. That's my critical number. So let's check that. So we're going to go to second calc. 0, enter, left bound. There we go, right there. Y is positive, then Y is negative, so I go back to positive for left bound, enter, enter, yes, and there we go. Now look, there's the 129. That's the square root. That was the value we had before. That was the square root of 5/3. That's our critical number, but we found out we didn't have to write anything. Now I'm going to store that in alpha A. That's already in alpha A, so it's kind of cheating. I should have cleared there. Oh, sorry. Clear that on press store, alpha A, enter. Now there's my 129. Now I want to put that back into my original function to find the area. Well, my original function, if I go back and look over here, my original function is in Y1. So if I go back to the second quit, if I had vars, that's my variable, go to Y vars, enter, and enter this, and if I put a parentheses, this will evaluate anything I put in the parentheses at Y1. Remember, Y1 was my original function, so I can put alpha A in there. And press enter, and there's your 17.21. And I didn't have to write anything down after this. Remember, 17.21? 17.21. So that's the same thing. So we did the same thing, but we didn't have to write any of this stuff down. So that's kind of a nice way to do it. If you're using your calculator, if you know how to use it, it can save you a lot of time and effort. So I hope that helps. Try to look over these things and think about these things. I know time's always an issue, but you know, you got to put the time in.